నేను పట్టుకుంటాను నెక్స్ట్ అని ఆడ పట్టుకుని వెళ్ళిపోతున్నాను నేను పట్టుకునేతోనే కావాలి డ్రాఫ్ట్ మళ్ళీ వేయరాదు అది పోయింది లాస్ట్ చేసిన చేయరా ఇట్లా పట్టుకుంటే ఇది రేపు ఎన్నింటికి పోదాం ఇంటికల్లా బయలుదేరు మొన్న మొన్న కనిపించలేదు నేను ఇక్కడ
We are going to start a new topic. So that is on job scheduling algorithms such as FIFO, capacity, FAIR. So in job scheduling algorithms, so coming to FIFO stands for first in first out, and this algorithm runs job strictly in the order they arrive. So this particular FIFO algorithm runs jobs strictly in the order they arrive. And next capacity algorithm, so it results dedicated guaranteed cluster slices for different business teams. So this particular capacity algorithm will be resolves dedicated guaranteed cluster slices for different business teams. And next algorithm will be fair algorithm. So it will continuously shifts resources. It will continuously shifts the resources. So every active job gets an equal share of processing power. So fair is nothing but it continuously shifts resources. It continuously shifts resources. So every active job gets an equal share of processing power. Let us break down this within real time IT example. So think of allocating, allocating cloud compute, cloud compute budget of a IT department. If they follow, if for job scheduling, if they use FIFO algorithm, so there will be a long and heavy backup backup job starts starts at 9 a.m. So let me backup job starts at 9 a.m. Here, చేసుకో తర్వాత నువ్వు చేసుకో ఏం కాదు కానీ ఇక నువ్వు చేయాల్సిన పని చేయమని నాకు ఇబ్బంది లేదు కానీ పెట్టుకో మమ్మీ అని అంటున్నా కదా నేనే డెవలపర్ in the FIFO algorithm. Developers urgent 2 second birth patch query is forced to sit waiting in the queue for 4 hours. So if you use first in first out, okay. So a long heavy backup job starts at 9 a.m. and a developer urgents 2 second bug patch query. If he is using a particular server, a 2 second bug patch query. So then this particular yes, goes supposed to sit waiting in queue for 4 hours. And next capacity algorithm. So this particular capacity algorithm will be using DevOps. DevOps tool. our team gets 50% of servers guaranteed. And the data science, the data science team gets 30%. And marketing gets 20%. Here, every different business team have the dedicated guaranteed cluster slice. And if you're using fair algorithm, it's a huge data, a huge data job is running, and a developer submits a small query. So if a huge data job is running and a developer submits a small query, so the system temporarily temporarily dials down the big job slightly to give the developer immediate compute power. If a huge data job is running and a developer submits a small query. Okay, so the system temporarily dials down the big job slightly to give the developer immediate compute power. Like in the fair algorithm, it continuously shifts resources. It continuously shifts resources. So every active job gets an equal share of processing power. So continuously shifts like resource continuously shifts resources. So continuously shifts resources. So every active job gets an equal share of processing power. And now we are moving to segment 5. the core ecosystem tools and real world. So let's speed up let's speed run the rest of ecosystem tools using real IT applications such as Apache Cassandra, such as Apache Cassandra. So we're coming to Apache Cassandra. You can think of a global Slack network. So this particular Slack network uses a peer-to-peer ring structure. Slack network is peer-to-peer ring structure. So there is no single master node in this particular Slack network. There will be no single master node to crash. Okay. If a in this particular thing, if a data center goes down, so even people can keep typing messages. So people can keep typing messages because every server can handle reads and writes. And next ecosystem tools will be Apache HBase. So we can think of a real-time fraud alerts. Okay. So while HDFS stores terabytes of past transactions, and this HBase acts as a quick access layer. This is going to act as a quick access layer. Looking up, it will be looking up individual users fraud. So looking up individual users fraud, and it flag status in milliseconds. It flag status in milliseconds seconds out of billions of rows. You will look up individual users fraud status in milliseconds out of billions of rows. And next will be Apache Pig and Hive. So this Pig lets you write clean data engineering sequences using Pig Latin. It's a simple script template. Pig Latin will be simple script template. And this Hive lets the business analyst write standard HiveQL HiveQL queries. So just SQL statements only, right? So just SQL statements. So that automatically into massive distributed task behind the scenes. It's going to be automatically compiled into massive distributed task behind the scenes. Now our 18th topic is on our 18th topic is on NoSQL, NoSQL characteristics, sources, relational SQL. Hmm. Let us look into the definition. So this SQL databases use rigid. This SQL databases use rigid, predefined tables with strict relationships, strict relationship rules. So which compiles ACID, which compiles ACID, which compiles ACID properties. So where A stands for atomicity, all or nothing, and C stands for consistency, valid state transitions, and I stands for isolation, independent execution, and D stands for durability, permanent changes, whereas stands for atomicity, all or nothing, C stands for valid state transitions, and I stands for isolation, independent execution, and D stands for durability, permanent changes. And it can scale by buying bigger servers. We can able to scale by buying bigger servers. So, coming to NoSQL databases, drop the strict structural rules. This particular NoSQL databases drop the strict structural rules, and they allow data formats to change on the fly. Allows data formats to change on the fly. They can prioritize raw performance. Prioritizes raw performance and scale up by linking many cheap servers together and scale up by linking many cheap servers together. SQLs are rigid, predefined tables. SQL or rigid and predefined SQL database are rigid, predefined tables with strict relationship rules, ACID compliance, and scale by buying bigger servers. And NoSQL databases drop the strict structural rules, allow data formats to change on the fly, prioritize the raw performance, and scale out by linking many cheap server together and scale out by linking many cheap servers together. SQL databases are rigid, mm, predefined tables with strict relationship rules, ACID compliance, and scale by buying bigger servers And NoSQL databases drop the strict structural rules, allow data formats to change on the fly, prioritize raw performance, and scale out by linking cheap servers together. And next, let us break down with a real-time IT example. So think of a spreadsheet. Think of a Excel spreadsheet. Excel spreadsheet versus Notion pages. So coming to SQL. So this particular Excel spreadsheet will have strict accounting ledger sheet. Here, if a column expects an integer, currency value, you cannot able to type a image link. You cannot able to type an image link or a sentence there without breaking the file. Okay? It's strictly accounting ledger sheet. If a column expects a integer currency value, you cannot able to type a image link or a sentence there without breaking the file. And coming to NoSQL. So here a Notion page, Notion page workspace. Okay, today you can paste text. Today you can paste text, and tomorrow you can able to embed a video or a checklist into the exact same file without redefining the whole workspace setup whole workspace setup. And next we are moving to the 19th topic, that is distribution distribution models. Sharding versus replication. Sharding versus replication. sharding versus replication. Let us understand this simple explanation. Sharding. Sharding is nothing but chopping a huge database into horizontal slices. Chopping a huge database into horizontal slices and scattering them across different servers. Scattering them across different servers. So no single machine runs out of disk space and scatter them across different servers. So no single machine runs out of disk space. Sharding, chopping a huge, sharding a like sharding, chopping a huge database into horizontal slices and scattering them across different servers. So no single machine runs out of disk space. And next, replication, making identical copies of your database, making identical copies of your database on multiple servers, on multiple servers, by making identical copies of your database on multiple servers, making identical copies of your database into multiple servers on multiple servers. So if one server breaks, the application stays online. Application um, making duplicates, making like replication, making identical copies of your database on multiple servers. So if one server breaks, the application stays online. Let us let us break down with an real-time IT example. So think of an enterprise email system. Think of an enterprise email system like Microsoft Exchange. So where you can able to see this, where you can able to see distribution models, sharding and replication. So coming to sharding distribution model. So like storing employee emails, employee mailboxes, mailboxes of the employees, starting name A to L on server 1 and mailboxes and to see on server 2. Storing methods, storing employee mailbox across mailbox A to L on server 1 and mailboxes M to Z on server 2. So because all employee emails all employee emails combined cannot fit on single server, cannot fit on a single hardware. If there is a if there is a reason that all employee emails combined cannot fit in a single hardware, we can able to chop a huge database into horizontal slices and scatter them across different servers. So no single machine runs out of disk space. Next, replication. Next distribution model will be replication. Replication. Syncing. Syncing live copy of server 1 to, to a data center in Ireland. Syncing live copy of server 1 to a data center in Ireland. And another copy to a data center in Ohio. Ohio. Another copy to a data center in Ohio. So so both European and US users experience fast load times, and high backup safety and high backup safety. Now we move to 22nd topic, NoSQL relationships. Embedding versus linking. Let us understand the explanation of NoSQL relationships. Instead of using SQL joins to link tables, okay. So NoSQL handles connected data. So here okay, NoSQL handles connected data by either nesting. So we can able to use nesting it directly inside the record by using embedding. Whether we can able to nesting it directly inside the record by embedding using embedding, or placing a simple text reference pointer to another record using linking. So instead of using SQL joins to tables, NoSQL handles connected data. NoSQL handles connected data by either nesting it directly inside the record, nesting inside nest, NoSQL handles connected data by either nesting it directly inside the record using embedding, or placing a simple text reference pointer to another record using linking. Let us try to understand it with a simple IT example, with a simple real-time IT example. So think of issue tracking tool. Think of issue tracking tool. So like Jira. Using embedding in issue tracking tool. Inside a single inside a single Jira ticket document. You nest we nest a list of comments. List of comments directly inside like list of comments inside the file. When when I load it, when I load the ticket, the comments load instantly. Comments load instantly. Just inside a single Jira ticket document. So like nesting a single like nested single and nested list of comments inside the file. So when I load the ticket, the comments load instantly using embedding. Using embedding, you can inside a single Jira document. So I can nest a list of comments inside the file. So when I load the ticket, the comments load instantly. It's about embedding. And next, linking. Instead of copying a 50 MB file attachment into every every single ticket, instead of copying a 50 MB file attached into every single ticket, I put a hyperlink. I put a hyperlink string reference. I put a hyperlink string reference. Like file underscore id colon double nine a double eight. Okay. So now it points company's central cloud storage looker. So then it points to company's central cloud looker. Instead of copying a 50 MB file attached into every single ticket, I put a hyperlink string reference file ID colon double quotes double nine eight double eight. So then it points company's central cloud looker. So it points company's central locker for the file. Next, we'll move to the 23rd topic, version version stamps and distributed consistency. So, 23rd topic will be version stamps, and distributed consistency. Let us understand what is version stamps and distributed consistency. So they will be unique tracking tags like timestamps or counters. So they will be unique tracking tags, tracking tags like timestamps or counters attached to the record to ensure that if two cloud nodes modify the same data item simultaneously. So unique tracking tags. I know one should book, sir. Unique tracking tags like timestamps or counters attached to records to ensure that if two cloud nodes modify the same data item simultaneously. Unique tracking tags like timestamps or counters attached to record to ensure that if two clouds modify the same data item simultaneously, the system can spot the conflict and prevent data overwriting. The system can spot the system can spot the conflict and prevent data overwriting So unique tracking tags like timestamp or counters attached to records to ensure that if two clouds nodes notify the same data item simultaneously, the system can spot the conflict and prevent data data overwriting. Prevent data overwriting. Let us understand within a real-time IT example. So think of a collaborative code editing on Google Docs or Git, right? Like collaborative editing on Google Docs or Git. Collaborative code editing on Google Google Colab or Git. Collaborative collaborative code editing on Google Colab or Git. So if for developer, say there will be two developer developer A and developer B pull version 5 of a configuration script. Configuration script at same time. At the same time. In collaborative code editing in a rule collab or Git, developer A and developer B pulls version 5 of the config script at the same time. At the same time, the developer A saves the changes first. Saves the changes first and updating the file to version 6. Updating the file to version 6. And when developer B when the developer B tries to save when the developer B tries to save the system checks the stamp system checks the stamp checks the stamps and sees developer B is staying. So when dev B tries to save, the system checks the stamp and sees the developer B is trying to update based on outdated version 5 and blocks version 5 and blocks the overwrite. అవ్వలేదా సరిగ్గా blocks the overwrite. Blocks the overwrite and prompts them to resolve the conflict. Prompts them to resolve the conflict. So in collaborative coding editing on rule collab or Git, developer A and developer B pulls version 5 of a configuration script at same time. When developer A saves their changes first and updating the file to version 6, where when developer B tries to save, the system checks the stamp and sees developer B is trying to update based on outdated version 5. So it blocks the override and prompts them to resolve the conflict. Now we are moving to the 24th topic. That is NoSQL Content Management System. NoSQL Content Management System. or CMS. Let us understand the explanation on NoSQL content management system using a flexible NoSQL database. Using a flexible NoSQL database to power websites with diverse media content highly diverse media content. So it is allowing administrators to store block text, videos, and dynamic user polls together easily. So using MySQL content management system using a flexible NoSQL database to power websites with highly diverse media content. The highly diverse media content, allowing administrators to store block text, videos, and dynamic user polls together easily. Let us try to understand with an real-time IT example. Consider consider we are building a platform like we are building a platform like Medium, Medium or WordPress. We're building a platform like Medium or WordPress. So here, so there will be articles in Medium or WordPress. So one might contain article might contain only text, and where another might embedded and interactive another might embedded interactive Spotify player. And the might third might have a gallery of images. Gallery of images. So, a NoSQL document. So, a NoSQL document store NoSQL document store allows this complete this completely this completely different layouts different layouts to be saved cleanly to be saved in to be saved in cleanly in the same database tables the same database table. So we are using a flexible NoSQL database to power website with highly diverse media content. So we are allowing administrator to store blog, text, video, and dynamic user polls together easily. And we are moving to the next topic, that is 25 on Apache Cassandra. On Apache Cassandra. Apache Cassandra. Apache Cassandra is for architecture and clients. Let us see the simple example. Let us see the simple example. Let us see a simple example. Let us try to understand this about Apache Cassandra in terms of architecture and clients. So this Apache Cassandra is a powerful decentralized NoSQL database. So that organizes its computer in a ring network. That organizes computer in a ring network with no single point of failure. With no single point of failure.
సరే ఆమ్లెట్ ఆమ్లెట్ ఏమవుతుంది
No single point of failure and capable of writing data. Capable of writing data at extreme speeds. Capable of writing data at extreme speeds. Developers use native client tools. Developers use a native client tools or a shell interpreter. Developers use native client tools or a shell interpreter. SQL SH. SQL SH to interact with it to interact with it using a SQL-like format called CQL. So, using a SQL-like format called SQL-like format called CQL. Apache Cassandra is a powerful decentralized NoSQL database Apache Cassandra is a powerful, decentralized NoSQL database. Cassandra is a powerful, Apache Cassandra is Apache Cassandra is a powerful NoSQL. Apache Cassandra is a powerful, decentralized NoSQL database that organizes that that organizes computer in a ring network with no single point of failure without with no single point of failure and like single failure capable of writing data at extreme speeds capable of writing data at extreme speeds developers developers uses a native client tools or a shell interpreter SQLSH to interact with it using a SQL-like format called CQL. SQL like format called CQL. Let us uh, let us try to understand it within a real time IT example. So think of a global IT telemetry, global IoT tele, telemetry, telemetry ingestion ingestion engine, like connected Tesla cars, like connected Tesla cars. So of cars, thousands of cars send battery status sends battery status data. Thousands of cars sends battery status data every second. So here the Cassandra, here the Cassandra serves as the decentralized ring database. Decentralized ring database that accepts constant wave of data. So like writing writes requests without logging. So it's constant wave of data writes request without lagging. Constant wave of data be write request without lagging and ensures their ensures that even 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 and root when entire AWS data center goes offline. database. Okay. Some instant wave of data writes request without lagging. It ensures that even 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 an entire AWS data center goes offline. The other nodes, so the other nodes in the ring keeps collecting telemetry.
నా ఫోన్ ఎక్కడ ఉంది? సరే
Hmm.
ఫోన్ ఏది నాది?